Okay, we are back and we are ready to talk about section 2.3. Just a quick review. In section 2.2, we looked at a few different ways that you can combine two functions. So you can add them and you have a new function that is f plus g. You can subtract them, multiply, and divide them. And in addition to defining those and doing some examples, we also talked about what the domain of those would be. So today we're going to introduce a whole new way to combine two functions and create a new function from them. And then we're also going to talk about what the domain of that new function is. So our new function is a composition of functions. So this is how we're going to combine them together. And the symbol for it you can see right here is a little open circle, kind of looks like a degree sign. And the way that I read this is f of g. And that really is a good description of what is happening here. We are taking, or we are evaluating, the function f, where we are evaluating it for whatever the result of g of x is. Okay? So it's f of, just like, we've done problems before where we've said we're taking f of 2, and that meant in the function f we would replace the x with the number 2. Here we are going to replace the x in the function f with g of x. And if it's one where we're evaluating that and we know what g of x is, we've already resolved that, then we would use that value. Otherwise, we're doing it algebraically. Okay, we're going to do this page a little bit out of order. I am going to go ahead and fill in this sentence here that's going to describe the domain, but then we're going to skip down and do some calculations and then come back and talk some more about domain. I think that's going to make a little more sense because I want you to understand what these are, and I think the domain will make more sense once you understand what the calculation is. But I'm going to go ahead and fill in the blanks here. This function is only defined, which means this is the domain of it, if x, the number x, or the value of x, is in the domain of g, and g of x, that means once we have done the calculation for g and found that result, that number, that result from g, has to be in the domain of f. So a little bit more here to figuring out the domain than we had in the last section with our functions that were combined using arithmetic. Okay, so I'm going to skip down here where it says calculate f of g and g of f, and then we'll come back and do the same question but with finding the domain. But we're going to use the same functions in both of these problems. So f of x is 4 over x, g of x is 1 over 2x plus 1. So we're first going to calculate f of g, and just keep in mind that when we're calculating f of g, it might not be defined everywhere. So really, we're calculating what it is for the points where it's defined, and then we're going to fill in and say, oh, but it's only defined in these places after the fact, which is a little out of order, but I think I just want you to make sure, I just want to make sure that you understand how to calculate these, and I think the domain part is going to click a little bit better. Okay, so just like I said before, this means f of g of x. And just like with order of operations, you always start inside parentheses. We're going to do the same thing here. We're going to go inside the parentheses. So we're going to take f of something, and that something is whatever the value of g of x is. And we have that right up here. G of x is 1 over 2x plus 1. Okay. Now we're going to apply the function f to that. And what that means is we're going to take the function f, so 4 over x, but we're going to replace that x with whatever's in the parentheses. So I have 4 over x, but x is this, 1 over 2x plus 1. And then we can simplify that. Notice that I kept this main fraction bar longer than the other one because that is the main one. It's important to keep that straight. But this is a compound fraction, which means either in the numerator or the denominator or both, there is another fraction. And we need to simplify that. And if you just keep in mind that fractions always mean division, this isn't going to be too bad. So it's 4 divided by 1 over 2x plus 1. How do you divide by a fraction? You multiply by its reciprocal. So we turn that upside down. Now, of course, we can put the 4 over 1 if that helps us. But we're basically taking 4 times 2x plus 1, and we can distribute that and get 8x plus 4. In the denominator, we're going to have over 1, so we can leave that off. So the function f of g of x, this new function that we just defined, is equal to 8x plus 4. But that's only for the points where it's defined, and we're going to come back to that when we go back up to the part we skipped here. Okay, now let's do the second half, g of x. These are not the same thing. It does matter which one comes first. So I'm going to take g of, always start inside the parentheses, replacing the f of x with what f of x is equal to. And now I evaluate the g. I'm supposed to take g of 4 over x, so that means anywhere there's an x in the function g, I replace that with 4 over x. Okay, I can do some simplifying here. 1 over, if I multiply the 2 times 4 over 8, or 4 over x, I'm going to get 8 over x. Really, I need to have just a single fraction in the denominator before I do the next step. 1 is equal to x over x. So I can add those two pieces together and get 8 plus x all over x. Remember, this is my bigger fraction bar, so that's the one that we're going to use as a division. Dividing by 8 plus x over x is the same as multiplying by the reciprocal, so I'm going to skip writing out that division step. So taking 1 times anything is just that thing itself. So I get x over 8 plus x. And that is our new function g of f. Okay, so what is the domain of these? So let's start with the first one. Domain of f of g of x. There's 2 parts. See this and sign here up here in the definition? X has to be in the domain of g, and g has to be in the domain of f. So let's start with this first one. X has to be in the domain of g. So we look at the function g and say, what is the domain? This is review from the last section. Domain of a fraction means that it's the numbers that do not make the denominator 0. I'm going to change this from an equal sign to just kind of saying this is where we're doing our work. So x, the denominator of g cannot be equal to 0. Subtract 1 from each side, divide by 2, and I get x is not equal to negative 1/2. So that's this first half. X has to be in the domain of g. That means that x cannot be negative 1/2 because that would make the denominator of g 0. So then g of x has to be in the domain of f. Well, what numbers are not in the domain of f? Just 0, because the denominator of f is 0. So that means x cannot be equal to 0, but this doesn't say x has to be in the domain. It says g of x has to be in the domain. So that means g of x cannot be equal to 0. I plug in g of x, 1 over 2x plus 1 is not equal to 0. Actually, the solution to that is all real numbers, because to solve that, I could multiply both sides by 2x plus 1, and that would leave us with 1 equals 0. So that's all real numbers. So that doesn't give us any new information. So the domain of f of g of x is just x is not equal to negative 1/2. Or if you want to write that in set notation, it would be negative infinity up to negative 1/2 union negative 1/2 up to positive infinity. Okay, now let's look at the domain g of f. And just like the functions themselves are different, the domain is different, because this sentence just gets turned all around. So this sentence was originally written for f of g. We're now talking about g of f. So x is in the domain of f, and f of x is in the domain of g, because we've switched what we're talking about here. So let's start with this first half. X has to be in the domain of f. What is the domain of f? It's everything except x equals 0. So that just gives us that x cannot be equal to 0. Now let's look at the other half. F of x has to be in the domain of g. Well, what is the domain of g? The domain of g was, we calculated it over here, it was all numbers except -1/2. So f of x cannot be equal to -1/2, which means 4 over x not equal to -1/2. Multiply both sides, or however you like to do it, cross multiply, you get 8 equals -x, which would be, and again that's not equal to, x is not equal to -8. So what is the domain of g of x? It's x is not equal to -1/2 and x is not equal to -8. In interval notation, that would be -∞ up to -1/2, union with -1/2 up to -8, union with -8 to infinity. So it's basically all real numbers with just a couple holes, the -1/2 and the -8. Okay, this next one down here is actually a typo. This was supposed to say, what is f of g of 2? Because we've already calculated just the generic f of g. But let's just say that we wanted to evaluate that at 2. Two ways you could do it. One is you could actually start from scratch and calculate that. And if you haven't already calculated the generic f of g, that's what I would do. So again, working inside the parentheses first, g of 2 means that in the function of g, I replace the x with a 2. So 1 over 2x plus 1 becomes 1 over 2 plus 2 plus 1, or 2 times 2 plus 1, which is 2 times 2 is 4 plus 1 is 5. So we get f of 1/5. And now we go to our f function and replace the x with 1/5. Keep track of which fraction bar is the biggest, because you need to actually do that division. So we get 4 divided by 1/5, which is the same as 4 times 5, or 20. Okay, like I said, that's one method. The other method is if you've already calculated f of g, right up here, we calculated the generic, and all the way over here to the right, we found that that was equal to 8x plus 4. So if you've already done that, you can just substitute the 2 into that final result. I'm adding extra parentheses here for some reason. I'm not sure why. Get rid of that one too. Okay, so 8 times 2, that was our x, plus 4, 16 plus 4, and we get that same result of 20. Okay, I think I'll stop here, and we will come back on the next video and talk about how we flip this around. What if we're given a function and we're asked to rewrite it as 2 functions? So we're going to kind of go the backwards direction in just a moment in the next video. So take a break, come back to it when you're ready.